So one thing that at least kind of helps me a little bit is when we're going and we're obviously having to do a bunch of math and look at it, just think about what these units really stand for. So really all we're talking about is numbers that happen to be anchored in actual values, things that we can measure. And obviously this is all in the metric system. So when we're looking at the letters and what each of them mean, here's just a nice little conversion for linear motion, which is what we've covered so far. And then we have over here, which is rotational movements. And that's what we're going to get into in the next exam of class. So the first metric we have is time. And obviously time is forever marching forward. This is giving us obviously the unit in seconds, hence the S, what we see. And then when we're looking at units, you can see when we're talking about shorter and shorter periods of time. Now, don't worry about that, just more or less understanding the way that we anchor on base 10 when it comes to the metric system. Now, then we have distance. So that's going to go ahead and be the distance, obviously, that we're going to be able to measure with a measuring tape. Now we're doing this in meters. It's important to realize that, okay, we can convert relatively easily. So 1 inch is 0.0254 meters. 1 meter is almost 1.1 yards, and that 1 meter is going to be about just a little under 3 1/3 feet. So when we take distance and time, we now have velocity, and that's just the meters over the seconds. So speed would be how fast we're traveling. Velocity is going to be speed in a given direction. So your speedometer might say you're going 80 miles an hour, but if we're looking at how fast you're covering from point A to point B and just purely the horizontal, you're actually going to probably be going a bit slower than that, because if you're going up or down, we have, remember, a vertical and a horizontal velocity. Now, we then get ourselves into acceleration, which is going to be the change in velocity. So we've got meters per seconds times seconds. And so we can figure out how we're changing our velocity with time. And so this is going to be obviously useful when we're looking at things that are not moving to things that are moving, things that are slowing down rapidly, or whenever something is changing direction. That's when we're going to be undergoing acceleration forces. And obviously gravity is constantly having all of us under a set amount of acceleration. Now, obviously we've covered this before when we talk about the weight of an object is not the same as the mass, because it's going to come down to the wonders of how much gravitational force we happen to be under. Now, 1 kilogram itself is going to be the same as about 2.2 pounds. And so we can go ahead and modify these things effectively with how much force it's going to be experiencing. Now, we're always going to have this going on, whether we're sitting down, we're falling, or we're standing. The key is how we're overcoming or feeling lesser or greater effects of this acceleration. Now, force itself, for what we're going to be talking about quite frequently, is just the combination of that mass of the object multiplied by its acceleration. Now, this is going to give us our units, which is known as newtons, or kilogram per meter divided by time squared. Now, obviously, there's lots of different ways that we're going to receive these forces. Now, typically, we're looking at things like gravity, but we talked about friction when we have the normal force pulling two objects together, and then obviously what's occurring with those two interacting. We're not worrying about magnets in this class. You do have applied forces when we talk about conservation of momentum and inertia. When we're moving something, we're going to touch on very much so at the end, buoyancy force. And also we're going to be talking about tension, and we've touched briefly on spring forces, but we're not going to go too far into those. Now, momentum itself is going to be the combination of the mass of the object multiplied by the velocity it happens to be going. So this is going to be usually AM is what's going to stand for our momentum. And like anything else, the larger the object or the faster it's going, the greater the amount of momentum it has. And work itself is going to be the total amount of force we're doing and the distance we happen to be covering. So this is just a good way to look at those force vectors of how, yes, if you're carrying the briefcase, you've got the upward force you have to lift while you happen to be going across the ground. It's going to require a greater amount of force to carry an object up a flight of stairs, and effectively how we're going to have these Newton meters being produced with anything we happen to be doing. Now, this then lends itself to power, which is going to be done in watts, and this is literally going to be work over time, or we can think of it as our force times our velocity, or simply the force times the displacement, how far it's gone, divided by the time it took to do so. So the key difference between literally work and power is simply the amount of time it took you to do something. If you've done it faster, it's not going to take as long. Now, obviously, we've started to touch upon looking at degrees. So when we talk about a circle that happens to have a radius of exactly 1, this is giving us, when we're looking at the different trig functions, the numbers that we are getting whenever we're looking at using our sine, cosine, etc. So literally, if we know that it happens to be a radius of 1 at 45 degrees, and a squared plus b squared equals c squared, because we're making that triangle, okay, the right angle triangle, then we know both these will be the same. So it's the square root of 2 over 2 for both the x and the y coordinate. Because then if we go ahead and a squared square this, so we get 1 over 2 equals 1 over 2, so, or plus 1 over 2. So that's going to give us 1, and then 1 squared equals 1. So that's going to equal our hypotenuse. And that's all we're doing when we happen to be looking at these angles. Now, angular velocity is how many degrees we're going to have gone within a certain period of time. Now, obviously, the longer the radius is, the further the actual true distance will have gone rotating around. But for now, it's just going to be the number of degrees that happen to be covered within a set period of time. And that looks like what is a lowercase w. Now, rotational acceleration is the same thing that you're seeing whenever we're talking about normal acceleration, where it's just going to be the change in velocity multiplied by that change in time. So obviously, if we go from no velocity to a much higher velocity in a short period of time, we're going to have a very large acceleration. Torque is going to be the combination of our force multiplied by our lever arm, which is going to give us what's known as Newton meters. Now, torque is incredibly important with literally all of the movements of the human body, because I'm creating torque by contracting my muscles to move my bones, which in turn is going to articulate my body wherever I want it to go. And we're going to have the same type of inertia, both rotational and linear, which is literally just going to be the mass of the object multiplied by its current acceleration. So the faster it's moving, the greater the inertia. When we're talking about rotation, now we have the mass multiplied by the radius of the object. So the heavier object with a greater radius, it's going to have a greater amount of inertia. Think back to a carousel when you guys were a kid and spinning that, as opposed to spinning something like a small top. It's got a much smaller radius and a much smaller mass, so it's much easier to affect the change. And an axis of gyration is simply going to be the axis of which an object is going to rotate. So this was just a way to kind of help you guys talk through the units. Maybe, I hope, for a couple of you guys, it's maybe made some things make a little bit more sense. And actually, I don't even know why that's there. That's for bioenergetics. That's kind of funny. So this is effectively your review, guys. So we can cover anything you guys want to cover. We can talk through any of the questions on the practice exams. This is all totally up to you guys. Otherwise, if you guys don't have any questions, you guys feel ready to go, then we can just call it a day. And okay, good question. When do we use initial velocity? Do we just use it to find the horizontal and vertical velocities? Do we always deal with horizontal and vertical components separately? So yes, you're going to use it to figure out what would be the horizontal and vertical if we're talking projectile motion. Also, whenever we're doing acceleration, so if we have an object that's starting off at 10 meters per second and it's deaccelerating at 2 meters per second, how far will it have gone in blank amount of time? Or how fast will it be going in blank amount of time? So that's where we're going to go ahead and make sure that we're using that distance formula appropriately. So hence we'll need that initial velocity. And then same thing if you're trying to solve for what something's current velocity is going to be after it's been moving for a little while. Good question. You can do that on your own. The basic idea is you're just trying to look at the angles, and otherwise you can try to take a video of yourself doing the different movements, and then from there you're going to go ahead and see how far the angles have changed whenever you're doing those positions. Well, in a perfect world, you use what's known as a goniometer, and you can borrow one from the lab to go ahead and take care of that. The walkthrough video is currently online, so you just have to go ahead and follow the instructions there. So all you're going to go ahead and do is you can just take the video, literally, here's you externally rotate as far as you can, and then go ahead and get yourself as far internally rotated as you can, and then go ahead and do the same thing from the other side. Now on the YouTube site, there are literally the walkthrough of how you do it. You're going to only look at your joint for that movement. So hence you're going to pick the exercise, and then you're going to do your best of trying to figure out what is going to be the movement and the degrees of which you're going to see for each of those phases of movement. Gabby, your best form of review is to go through the study guide. That's the best way to go about this. Absolutely, Kristen, that is correct. So what's going to occur is that ball will have gone up and keeps falling since it's been 2 seconds. So it actually would be at negative, 6.76 meters. So you would have had to have thrown that ball from the top of a building for it to actually have been in the air for 2 seconds. All of the videos you guys are looking for the lectures, remember I upload them to the YouTube channel. So you just need to go look them up there. They'll be in the Biomechanics 2020 lectures and labs. Pretty much all of the questions on the exam review are going to be quite similar to what you're going to be seeing on the actual exam. And when will y not be equal to 0? Whenever it doesn't need to be equal to 0. So if we were to try to figure out effectively the flight time for throwing a ball from So right now I'm in the Moberly building. So if I was standing outside the building and I threw a ball up on top of the roof, well, it's going to be starting at wherever my hand's at. So that's probably going to be, we'll say 2 meters off the ground. But the roof itself is probably more like 7 odd meters off the ground. No, it might be more like, might be closer to like 9 or 10 meters off of the ground. So from there, that's where I'm going to have an initial y. So that would be on that plus minus side of 2. And then our final y is going to be equal to effectively 30. And so from there, I could have, say, it took the ball 2 seconds to get there. Well, from there, you're going to be able to then solve for what our initial velocity was. Can we go over number 7 or 16 on the review? Yeah, give me a second. Let me pull it up. All right. So number 7, if an object has a coefficient of restitution of 0.5 and is dropped from 7.5 up, how far will it bounce on the second bounce? Okay. So remember, our coefficient of restitution is how much percentage of its initial height it will hit after each bounce. So after one bounce, we'll have gone from 7.5 to 3.75. Okay. So then for the which that'll give us 1.875 meters. Then number 16. Okay, so this one's wild because notice it's going to be more than so that's going to go from 16. Well, I guess 16 times 16 is going to give us, so 1.6 plus 6 plus 3.6. So that's going to give us 25.6 meters, I believe. I could be slightly off there. What else do you guys want to talk your way through? $14, how much force do you need to create to keep a block moving with a static friction of 0.9 and dynamic friction of 0.8 if it weighs 4,500 newtons? Okay, so it weighs 4,500 newtons. So we need at least, it's going to be some factor of that. Now notice it says to keep a block moving, which means if it's keep a block moving, which of the two frictions are we going to use, guys? Bingo. We're using that kinetic friction, also as a dynamic friction. So it's going to be multiplied by 0.8. So we're going to take that, 32, About what? So let's go down to 20, since that was a question. Okay, so notice this is going to be pressure, okay? So you figure they're both going to deaccelerate at the same rate. So you just need to make sure you have something relatively consistent. So you want to have the higher, you're solving for pressure, literally tells you. So what you need to do is you need to take that softball that is equal to 0.25 kg, okay? It's going to be traveling at 10 meters per second, and we'll just say that its deacceleration is going to be 10 meters per second just to make life easy. Because we're going to say they're both going to do the same basic property. Okay, and so remember, pressure equals force divided by the area. Force equals mass times acceleration. So .25 times 10, and then order of operations, guys, is always a big deal. It's something easy to mess up if you're not paying attention. Then we're going to divide that by its surface area, which is going to be 0.024. So baseball pressure is going to be equal to open 0.15 kg times again that 10 meters per second squared deacceleration we're going to have it have when it hits. And this one is going to be divided by a grand total of 0.0136. What are the questions you guys want to work through? Going once. Going twice. Ah, there you go. All right, so we have here is going to straight up be a vertical, or not vertical, but a distance formula. So what we're trying to find is how far is it gone. So we just have an x equals, okay, for 25, our initial velocity is going to be 15 meters per second, and it's going to do that over 5 seconds. Now, notice we've got a plus, but we know our acceleration, it says deaccelerating, so it's going to be negative, okay? 1/2 times 2 times, we'll put that in parentheses so you can see it, it's going to be 5 to the second power. So x equals 15 times 5, which is 75, and then 1/2 times 2, which is 1, times 25, so it's going to be minus 25. So we're going to be left with our total distance equals 50 meters. What other question you guys want to work on? $17. All right. If a ball is thrown at a 40-degree angle, at 15 meters per second, flies for 2 seconds, how far will it have gone horizontally? All right, guys, so what is the first thing we need to do? It's the first thing we need to do. Trig, yes. Which trig function? Bingo. So we're going to take the cosine of 40 and multiply that by 15. And that's going to give us our horizontal velocity, h, which we'll figure out what that is in a few moments. So then we're going to take that horizontal velocity and put it into that distance formula. And since we don't have to worry about acceleration, we're just going to take that horizontal velocity and multiply it by 2. And that's going to equal our horizontal distance, which is going to be equal to some number of meters. This is going to be meters per second. So take your happy calculator. We've got trig, we're in degrees. So we got trig, hit our cosine. We get 0.766. Multiply that by our velocity, which is going to be 15. Hit the equal button. So then we get 11.49, which in turn means that we're going to have gone a grand total of 22.98 meters. Yes. For the vertical, we would use the sine, because remember, sine equals the opposite over the hypotenuse. And the hypotenuse here is that 15. And the opposite is the y, is the vertical. Now, if we were trying to get, like we did there, we wanted the adjacent because we wanted the horizontal. That's why we did cosine. Okay, for 12. Yeah. Yeah. For that one, you just take the cosine of 30 degrees and then multiply that by 800 newtons. All right, so next problem, I imagine you're referring to around 20. Wait. 17, yeah. Yeah, so here it would effectively go and just, yeah, y equals velocity times time, absolutely. So here would be the sine of 40 times 15 equals the vel equals some meters per second. And then we would take that vel and multiply it by 2. The intention is for Thursday to be a review, but if there's not really any questions, I'm just going to start on lecturing for the next chapters. Because I don't like sitting in silence. So since there's no gravity, you don't have to worry about, you just plug a 0 in for the acceleration for the vertical. So obviously anything multiplied by 0 is 0. So it's good. It just makes it a moot point. Now, whereas, yeah, for 19, notice we'd still have, well, we'd have, it's only 10 meters per second, but we'd start it up the same here, only now it wouldn't be, it would be the vertical velocity times 2 minus the 1/2 multiplied by 9.81 multiplied by 2 squared, because time squared. And that would equal your vertical distance. Number 6. Okay, so now here's the thing. We've got, notice we have kilograms. We don't have force there. So force equals mass times acceleration. So we've got 200 mass, but we still need to convert that over into the force. So what we would instead have is 200 times 9.81 times 2, and then all of that divided by 1. Which is going to be obviously higher. Okay, for the lab, you are going to do your joint of your movement in the different phases of the movement. And you will be filling out and trying to measure all of the other parts for your own movement. So give me 1 second, and I'll set the goniometers out in the lab. So if you guys want them, they'll be sitting on the table, but I will be right back and I'll show you one. This is also in the YouTube site, so you can see this as kind of the workup, but that's okay. Be right back, guys. Go ahead and put up more questions you guys want me to go ahead and review. Okay, so this is that goniometer, so we can actually see how far the angles have gone. So you'd start it, so say on my shoulder here at 0, and then as I lift my arm up higher and higher, so we would go and try to measure it to see how high I made it. Now, mind you, I can go higher, so this is going to be probably a bit more accurate. But we're looking at the joint and then how it's going to articulate there. Okay, so Taylor's question is, yes, we're doing all this stuff on Earth gravity. So hence it's 9.81, unless I go ahead and put otherwise in the question. Yeah, Jordan, no worries. We did an entire presentation on thinking in units. We really didn't answer many questions. It just, you can see the parts where we've put in answers as we go through. There's a whole lot we haven't touched. Okay, you're going to do internal rotation. That is going to be taking your shoulder and internally rotating it. You will measure that. You will then do external rotation, keeping yourself starting neutral, externally rotating as far as you can, measuring that both sides of the body. You will then do shoulder flexion, which is going to be taking and lifting your arm as far overhead as you can. You will do extension, which will be bringing your arm behind you as far as you can. You will then do hip internal rotation, which is going to be taking and turning your hip inwards and then externally rotating, trying to turn it outwards. You will do hip flexion, which is going to be lifting that leg up as high as you can. You will do extension, putting that foot as far behind you as you can. You will fill out all of the things that are on here. Then you will go down and write in your exercise. From there, you have the preparation, which will be the getting set to do the movement. You write in the joint you are doing. You will be doing the same joint for all parts. And you will then say how this joint moves during that phase. You will have the wind up, which will be pulling yourself in a position, putting a stretch on your muscles, and what joint that is, how many degrees of movement you'll have. You have the force producing phase. So this will be when you're actually contracting the muscles and applying force to the ground, the object, etc. You will have the same joint you just did, and then how far, how many degrees it will move. And then finally, you will have the follow-through phase, which is going to be after you've done applying force to the ground, same joint, and then how that limb will keep moving. So if we were going to say the vertical jump and you had the knee, preparation is just standing there. So your legs are going to be straight or mostly straight. So your knees are going to be pretty close to 180 degrees. Okay. So be pretty much, pretty much right at 180 degrees or a little bit shy of it. Then your wind up is going to be when you squat down. Your knees could be at 90, they could be a little bit less, whatever happens to be where you're at in the bottom of that movement. You're then going to have the force producing phase, which is where your legs are going to go ahead and obviously straighten themselves. So you're going to have the total amount of degrees that it moved during each of those phases. And then finally, you have the follow through phase, where now that you've jumped in the air, your knees probably aren't moving at all because it turns out you're in the air. So you're not going to see much of a change except until we land again. And that's where we're going to see that bend. You might rebend further, you might rebend less, just depends on how you choose to land. Once again, all these instructions are already online for you guys to go through. What other questions you guys have for me? Yeah, the next lab also you guys can start on is pretty easy. You're just going to measure your height, your wingspan, so how far you are fingertip to fingertip, how long your hand is, how long your foot is, just measuring the lengths of different parts of your body. Yes, you can come to those in the lab. When you walk into the X-Phys lab, you're going to see the stereo and then you're going to see a table. They'll be sitting on the table. Wipe them down with the wipes that are sitting in the lab before you use them and when you finish. You guys have any further questions? Yeah. So the next lab, whenever you're doing, let me go and pull that bad boy back up. So lab 2, bingo, you can do all these measurements by yourself. It's going to be a little weird to do some of them. If you guys don't have a fabric or like a measuring tape you'd use for girths and otherwise, get a string and then mark the string, the lengths, and then use a ruler to measure the length of said string, okay? But you can do all of these at home. Now, lab 3 with a vertical jump, we have an example online that you guys can use directly off of the YouTube, okay? Now, here's the key. You need to make sure that you're still doing the math to figure out the vertical jump height because it will not give that to you. Same thing with the rate of force development. So you're gonna have to pay attention and do some projectile motion, work with it. Lab 4, same type situation. We've got an example of somebody standing on the force plates. So you can go ahead and see, or sorry, it's gonna be laying down on the table, figuring out where their center of gravity is based upon their mass, the height, length of lever, and everything else, but all that information is given to you. And then finally, with a clean pull, you're going to find all of this stuff available for you guys online. And then I think also the postural sway, all of those should be up there. So some, the labs you could come in and do, we'll have it set up that you can run it on yourself. That's why we've got the wonderful reference to the YouTube series. You can see how we calibrate the force plates and run that on your own. But otherwise, you're going to be able to do that and not have to worry about, more contacts, which increases your risk of the COVID. And that's what I want any of you guys to get. Now, when you guys do submit your labs, so like obviously they're all on the same sheet. Do not submit the entire sheet. Just submit lab 1 itself, okay? Lab 2 and everything on, just delete it. So it's only sending the one lab at a time. Just because when we get to lab 5, if I have to scroll through 5 pages for every person, it just takes a lot longer to grade, which in turn takes more time and it's just kind of a bother. So we'll make sure we covered that. What other questions, comments, concerns you guys got? Are there a number of you guys that want to come in today and do the Goniometer Lab, either with a partner or obviously try to measure it by yourself? I will be here. I'm going to go get my COVID booster shot at 11, but then I'll be back in the lab, working on different projects for a while, and then I'll be back. Then I'll probably be trying to leave campus by 5, so the lab will be locked up after that. Yeah, it's fun. I got lucky. I was on campus one day and during the break, and my boss shot me a message that they had extra doses of the vaccine, and if you wanted to get it, you just had to go over and get stabbed. Yes, the lab is open on Fridays. Lab's open during most normal business hours, like 9 to 5, figure Monday through Friday. The lab is Moberly 223. It's on the syllabus. No worries, Taylor. Okay, so now this right here, guys, This is a momentum formula. So this is going to be simply the mass multiplied by the velocity. So an athlete runs along at 5 meters per second and hits a cart, okay, that he pushes along with completely preserved momentum. So that means they have that person has an initial momentum of 50, knows its mass, kilograms, multiplied by the velocity. Now, what we then need to go ahead and figure, that's going to give us a grand total of a okay. So if it's completely preserved, meaning this is going to be the pre, that means the post momentum will be 350. Okay. So now, how much mass is moving? Post, how much mass do we have moving? Bingo. We have 120 kilograms because we have the mass. So that means what we have is now 350 equals 120 multiplied by the post velocity. So what that means is our new velocity is going to be 350 divided by 120 equals our post velocity, which is going to be equal to about 2.92. What other questions you guys want to work through? I think, no offense, guys, since it's taken a little bit of time between each one to kind of figure out the next question, we'll go ahead and call it a day with the expectation that you guys are going to spend the rest of the time this morning working your way through this study guide. And that way, whenever we come back on Thursday, you guys are going to be able to tell me which questions you were not able to find the solution for, and we can work through them. Does that sound like a good plan to you guys? Awesome. Well then, stay safe out there, guys. Take care of yourselves. Work your way through this. Try all of them. Notice at the very beginning, gravity is at 9.81, and then just some basic information on what you guys have. But always, 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 when you're taking any of the quizzes or exams or anything, I want you to, sorry, my wonderful computer doesn't allow me to hit the top bar right now when I'm lecturing, because that's where like the Zoom controls are at the very top of the screen. But always have this up in the background. Okay? No interest in you guys memorizing the formulas. It's understanding how you use the formulas. That's the key. So stay safe out there. Keep working hard. And I will see you guys on Thursday morning, where we're going to finish up the review. And if you guys don't have any questions at all, then we're just going to go ahead and lecture a little bit over chapters 7 and 8. And then, yeah, you guys have your exam. You have to have it done by effectively the end of the day of Tuesday next week. So, toodaloo. See you guys then.